This is Scholar Strife doing some math today in Algebra 1. We're going to fit line to some data. So a scatter plot is a graph used to determine whether there's a relationship between paired data. And it basically looks like the three graphs below. You just plot points. You don't, there's normally not a line, but if it does look like all the points are going in a general direction, we can draw a line to maybe predict what's going to happen in the future, depending on what that data is. So if it's mostly going up from left to right, so if you look at the dots and if you can draw a line in between them all, there's a positive correlation if it's going up from left to right. And if it's going down, then it's a negative correlation. And if you can't tell, like if it's everywhere, then there is no correlation. That means one variable does not affect the other. And this is very closely related to slope. So if you have a positive slope, then you have positive correlation. Negative slope, negative correlation. Line of fit. So this line of fit is we try to make a line that goes through basically in between all the points. And if we want to make a scatter plot, well, we'll go through these 4 steps, but make a scatter plot. Decide whether the data can be modeled by a line. Draw a line that appears to fit the data. And then write an equation using 2 points on the line. So here we go. Let's do some examples. So we'll go through those 4 steps in an example, but not this first one. Describe the correlation of data graphed in the scatter plot. So the relationship. So here it looks like it's going downward from left to right. So this is a negative correlation. Okay. Here, it kind of looks like it's everywhere. Like you could say it's increasing, but there's a dot here, a few dots down here. You can't really tell. So this is no correlation. Okay. Example 2. All right, make a scatter plot of the data and then describe the correlation. So they just want a scatter plot. That means just dots, no lines. Okay, so we go x is 1 up to 3. That's the first point there. And then 1.5. So in between 1 and 2. And then 1. And then 2, 1. And then 2, negative 0.5. Which is right here. 3, negative 1. 3.5, negative 0.5. And 4, negative 2. Oops. Wait. 3.5, 0.5, 4, negative 2. Okay, as it kind of looks like it is looks like there's a negative slope. So negative slope means negative correlation. So from left to right, it looks like the dots are going downward. All right, let's move on. The table shows the average attendance at Chugiak High's varsity basketball games for various years. Write an equation that models the average attendance at varsity games as a function of the number of years since 2000. Okay, so they want us to first do our scatter plot, and then we're going to write an equation that depicts that, the data. So let's look at this. 2,488. Okay. So years since 2000, so this would be 0, 1, 2, 3, 4, 5, 6. Okay, 488. Let's say that's around here. And then 1 year after 497, so that's even closer to 500. And then 2 years, 525, so in between 500 and 550. And then 3 years, 567. 4 years, 583. 5 years, 621. 6 years, 688. Okay, so this is a positive correlation, but they're not asking for correlation. They want us to draw a line. Okay, so we need to choose 2 points. So you want to choose 2 points that, if you were going to connect the dots, they would create a decent representation of going in between all the lines. So let's say I wanted to choose this one here, which is 1, 497. Okay, the 2001. And let's choose here. If you would connect the dots and create a line there, so let's do that. Okay. See how it mainly goes in between all the lines, or all the dots there. The line goes in between all the dots, or tries to. Sometimes you can't get them all, or sometimes you can't get between them all, but you need to get through most. So choose 2 points where that works. Okay. So I chose those 2 points. I chose year 1 and year 5. So year 5 was 621. Okay. So once again, you can choose any 2 points that you think would work best to draw a line in between. And then once you pick 2 points, go ahead, draw the line. You don't need to circle the points. You just need to at least write them out so I know which points you're using. Okay, and then just like in the previous unit, we're going to find slope. Okay, so remember the formula is y2 minus y1 over x2 minus x1. Remember, this is rise over run. Okay, and once again, this is x1, y1, x2, y2. Okay, put it on in numbers. 621 minus 497 over 5 minus 1, which is 124 over 4. 124 divided by 4 is 31. So that's my slope. Okay. So find y-intercept. So in this graph, it's where it crosses the y-axis. And we're going to use the 0 year, because that is where it crosses the y-axis. So the 0 year is 488. Okay, so that's my b value. B value is 488. So we're going to make our equation. Y equals mx plus b. So y equals 31x plus 488. Okay? And the reason why we create these equations is to somewhat predict the future based on our data. So I could calculate how many, I could calculate the attendance in 10 years or 11 years. It seems to be going up by 31 each year. But of course, there's got to be a limit because Chugex has games, I meant wherever they're hosting it, unless they're going to start hosting it at the new arena, it's going to eventually reach capacity. But we can try and predict at least, you know, the 7th year or 8th year. Alright, checkpoint 1. Make a scatter plot of the data. Describe the correlation. Okay, so 1, 5, 2, 5, 2, 6, okay, 3, 7, 4, 8, 5, 8. So you can tell this is going upward from left to right, positive correlation. Okay. So now we got to make a graph. Okay. So so we need to choose an X and Y. Well, I mean, X is the bottom right here, and then Y is the top. And we want to choose a scale, basically. Now the bottom is easy. We have 1, 2, 3, 4, 5, 6, but let's spread them out. So let's say every 2. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And we'll call it 0. Okay. Now here, you want to fit all the data. So we're going to look at the Y values of 65, 76, 82, 86, 92, 97. So they all fall between 60 and 90. So we don't really need 10 through 50. So I'm going to say this is 60. And we can either go up by 5s or by 10s. So let's try and check this out. Let's say we go up by 5. So this is 65. And this is 70. And then 75, 80, 85, 90, 95, 100. Okay. So you want to choose a scale that would fit most of your data using the most amount of space on your graph. All right, here we go. So 165, 276, so a little above that there. 382, 486, 592, and 697. Actually, it's right around here. Okay. And then you want to choose 2 points that would best encompass the entire graph, go in between all the points. So I'm going to use can use any 2 points you want, but I'm just going to use 486 and 697. Okay, and then I'm going to draw a line connecting those. Make sure you use a straight edge. Can I undo? Oh, I can. Cool. Alright, let's try this again. Ooh. Yeah, please use a straight edge. Especially when you're doing this in your science class. Okay. So now, we're going to find our slope, because we have to write an equation of a line. Okay. y2, which is 97, minus y1, which is 86, over x2, which is 6, minus x1, which is 4. Which is 11 over 2, which is 5.5. Okay. So your slope, you can either leave it as 11 halves or 5.5. Doesn't matter. Okay, now we need to find the y-intercept. They didn't give us a y-intercept in this one for 0. Okay. Now we drew a line, but that does not mean we can use that particular point. We need to find it. Okay. So remember, we have y equals mx plus b. Okay. And we have a point. So I'm going to plug this point into my x and y. So y, which is 86, equals m, which we found to be 5.5, times, and then x, which is 4, plus b. Okay, so we'll get 86 equals 22 plus b. We're going to subtract, to get b by itself, we're going to subtract 22 from both sides. And we'll get b equals 64. So my equation is y equals 11 halves x plus 64. And that's all we have for today. Have a good one.